A ball is thrown off a 10-meter cliff at some angle such that the vertical component of velocity is 5 meters per second and the horizontal component of velocity is 8 meters per second. If the ball hits the ground at the bottom of the cliff, how far horizontally did the ball travel? Okay. So setup wise is we're going to start it the exact same. It's a 2D motion problem. So because it's a 2D motion problem, I use my black marker to make my list of two variables, delta x, vix, vfx, ax, t, delta y, viy, vfy, ay, and t. Because it's a 2D motion problem, my times are going to be the same. The times will be the same. The ball is moving freely through the air in 2 dimensions, therefore blue marker, it's a projectile, which means that my ax is 0. These, my velocities in the x are the same, and that is my ay is negative g, which on Earth is negative 9.8 meters per second squared. All right. Green marker, is it a horizontal launch or an angle launch? Angle launch, okay. So don't put a 0 there. Is it a delta y is equal to 0 problem?
No.
No, it's not this time, right? So here's my amazing picture. I have a ball, it's thrown at some angle and it goes whee, and it lands over there somewhere. The height of my cliff is 10 meters, and I'm trying to figure out how far it is from here to there. So this is not a delta y is equal to 0 problem. So it's an angle launch, not a delta y is equal to 0 problem. So that's really all we can fill in from problem types. Now, from information in the problem, we can fill in some additional information. So it says with a vertical component of velocity. So my vertical component, that's going to be my y, and that's how fast it leaves in the y direction. So it's going to have a 5 meters per second vertical component of velocity. Vertical meaning up and down. And it has a horizontal component of velocity, and that's going to be 8 meters per second. The other number in here is 10 meter high cliff. Where do we put 10 meters? Change your y. Is it? It is going to be a negative. Okay? This is going to be a negative 10 meters. A lot of you have not gotten the habit of putting down being a negative 10. This is going to have some issues in this particular problem. The ultimate question being asked, orange marker, how far away does it leak? So on the surface, this doesn't really look to be any different of a problem that we've done so far. And it's really not, except for the math piece is going to be a little bit different. So there's some options. I have 2 written out, and I'm actually going to change option number 2. So there's really 3 different options here. And I'm going to show you 2 of the 3 options. So option 1 is well, let's not even talk options. Our next step typically is to do what? If we want to solve for this, shoot, I don't have enough information, so I got to solve for time first, and then I can go. Okay? So if we just kind of keep that same kind of method going, we're good. And since I don't know final velocity in the y direction, I have to then choose an equation. And the equation number 3 is the equation that we have that doesn't have a delta y. Delta y is equal to VIT plus 1/2 AT squared. That's my equation. Oops, I forgot my y's. VIY A. So that's my equation number 3. Again, nothing different. We've used equation 3 way too many times, but once we get to this next part, this is where some potential math, issues might arise. And we get something that looks like that. Actually, let me do that just to illustrate what's going on. What are we trying to solve for? T. How many t's do I have? 2, right? So how many solutions for t are there? There's 2 solutions for t. So you have some choices on how you solve this, and choice 1 is to use the quadratic formula. And some of you will say, okay, whatever. I just got to plug numbers in the quadratic, no big deal. But other people are like, ugh, I don't like quadratic, I always screw that up, I don't really like that. Is there another option? The answer is yes. Okay, but if we move forward with a quadratic, we can simplify this a little bit, and this becomes -10 is equal to 5t minus 4.9 t squared. Now, in order for the quadratic to work, and it's listed on the top of the sheet, it needs to be an ax squared plus bx plus c is equal to 0 format. So this is our a, this is our b, this is our c, but it has to be set equal to 0. So we have to rearrange them. And it doesn't matter if we move the 10 over to here or we move these over to here. It doesn't ultimately matter. Would we rather move the 10 or would we rather move this side over? Would we rather move C or A and B? Which one do you want to do?
A and B.
Okay, so we can move A and B, but realize we could move this over. So just to do some quick, so if we're going to move the A chunk over, this was minus 4.9, so this becomes a positive 4.9 t squared. This is plus 5, so this is going to be a minus 5t minus 10 is equal to 0, right? So now, once again, this is our A, this is our B, and this is our C. And I put that negative sign in there on purpose because remember, it's in the plus format, so our B has a negative value. So then our quadratic is t is equal to, right, because we're solving for t, not x actually, and it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And in years past, I said, hey, isn't there a song? And you guys all start singing in your heads, because most people don't actually want to sing it out loud. But then we can go through and we should be able to plug in values, and we should be able to solve for this. So if we plug numbers in, t is equal to the opposite of b. So b is -5, so the opposite of -5 is a positive 5. Plus or minus the square root of b, which is -5 squared. Remember, that's positive. Your calculators will probably screw that up. If you go -5 squared, it'll probably tell you it's -25, but it's parentheses, -5 squared, minus 4 times 4.9 times c, which is a -10, all over 2 times 4.9. Now, I'm gonna be kind of lazy. And I already solved for these. But hopefully, we can double check all these. We get two solutions, and we're gonna get a solution of negative 1.006, and we get a 2.027. And hopefully, you can verify that I did that correctly. If I set everything up right, and if we input this all in correctly, those are our two solutions we should get for time. Can we verify? Yeah, we're good. We got them both. I didn't screw something up, hopefully. Okay, now we have to make the choice here. Which time do we want? So what we're really saying is, there's a time right here where it crosses this negative 10, because this is like 0 meters, so this is negative 10 meters. But realize this is parabolic, so there is another point that has a negative 10 meters for a value of time. But it was before I said go, right? On your mark it said go, it happened before I said go. Because it was never at this, because there was this cliff that it started from. So you got to kind of go through and say, well, which time do I want? And in this case, we want to make sure we choose the positive time. So our time is 2.027 seconds, 2.027 seconds. Like I said, some people are like, whatever, it's just quadratic, no big deal. And some people really, really, really despise quadratic. Once you've solved for time, our situation is very similar. In the x direction, we use equation number 3, that we say delta x is equal to VIX times t plus 1/2 AX t squared, and this is still 0, so my delta x is equal to 8 times 2.027 seconds, and my delta x is going to be right around 17 something. 2.027 times 8 is going to be closer to 16, I guess. Okay, 16.22 meters. If you're comfortable with quadratic and you say whatever, this is going to be the way, one way you could do it. The choice is yours. Okay? But there is another, well, there's two different ways. There's two different ways. There's one way that it says, but I'm actually not going to show you that way because I changed my mind after I hit print on these. So we could do a quadratic. The way it says that we were going to do it, which I'm not going to actually do the calculation, I'll show you how we could set it up though, is, so if we do this whole thing over again, we could treat it as a time to max height. So we have this ball that starts on the cliff and it goes whee, right? And right here, I know the velocity is 0 at max height. So the way that I was going to show you how to do it, I decided not to though, is what we could really do is we could treat this as two separate 1D motion y problems, and we could solve for the time it takes us to get to max height. Okay, we could solve for that. And we could call that like T1. Then I could go through and I could solve for the time it takes to go from max height. The time 2 is to go from max to ground. And then when we add those two together, we'll get total time in the air. This is not simply taking this number and doubling it, because it lands further down. It's going to take less time to go up than it is to come down, because it's going to fall for a longer period of time. That's the way I was going to show you how to do that. But then talked to Mr. Foster, and he's like, I'm like, oh yeah, there's that. I like that way better. So this is a different way we could do it, and some people are like, I like that way. That's an option. I'm not going to do it. Instead of doing it the time to max height, what I'm going to do is we're going to solve for V, F, Y, then time. Okay, so that's actually how I'm going to show you the second time. So if we treat this, well, we already did all my list of variables, right? So if we pretended like we never have seen this problem before, oh look, it's a 2D motion problem. Oh look, it's a projectile 2D motion problem that moves at some angle, and it's a delta y does not equal 0. This is the information we start with, right? So instead of doing it quadratically, which you could solve for time essentially in one step, you just got to find both solutions of your time and then choose the one that you want. The other way we could do it is, given our list of variables that we already had, this is what we started with. Ultimately, we're solving for delta x. But in order to get to delta x, we need to have our time. By choosing equation number 3, we had to do quadratic. The other option, though, we could go through, and if we solve for my final velocity first, then we could solve for time, and then we could do it that way. So it's a way that we can solve for velocity or time without doing quadratic. So instead of doing quadratic, you're doing 2 physics calculations, 2 Fab 5 calculations. So if we were to solve for final velocity in the y direction first, we'd have to choose one that we don't know time. So that would be equation number 4. VFy squared is equal to VIY squared plus 2a times delta y. My final velocity in the y direction squared is equal to 5 squared plus 2 times negative 9.8 times negative 10. That was not recycled. So my final velocity in the y direction squared is equal to 25 negative 19.6 minus 196, I think. Yep. Okay, so then, oops, negative and a negative, give me a positive. So my final velocity in the y direction squared is equal to 221. That doesn't seem right. Oops, that is not what it is. Yeah, 221. Then we take the square root, and my final velocity in the y direction is equal to plus or minus 14.866 meters per second. Square root of 4 is plus or minus. Now we need to make the choice. When the ball hits the ground right here, is it going down at negative 14.86 or is it going up at positive 14.86? Down. It's going to go down, right? So we have to choose the negative 14.866 meters per second. So negative 14.866. Now that we know our final velocity, we could plug it into a lot of ones, but equation number 2 is a fairly simple one. And we could say equation number 2, final velocity is equal to my initial velocity plus a times t. So we could say negative 14.866 is equal to 5 minus 9.8 times t. Do some rearranging and we get negative 19.866 is equal to negative 9.8 t. T is equal my t is equal to 2.027 seconds, which is the second solution we got in our quadratic, right? Right, wasn't it 2.027? So there's 3 ways. The nice thing about doing it this way is it's our same list of 2D motion variables. It's an extra step to find final velocity to then find time, but you save yourself doing it quadratic. The first option is you do the quadratic, but then you don't have to do a double Fab5 calculation. This option, the time to max height and the time back down, could also work, but you have to realize that this is a separate Y column variable list than this one is. So it works. It's not maybe quite as direct, because now it's really 2 separate 1D motion problems that we're kind of combining together to then put into a projectile. Is that a quick show of hands? Given the choice of quadratic versus solving for final velocity and then time, so doing quadratic versus 2 steps to find time, which one would you choose? So just one finger quadratic, 2 doing it the 2 steps. Okay, it's actually a pretty equal distribution of some people just saying, I'll do quadratic, some people doing it too. So the choice is up to you, is really how you set that up. So, yeah. That's all I really wanted to do together with you guys today. The rest of the time, there's some stuff that to work on. A couple angle launch problems. I had asked to stop at like 1 through 4. I'm not sure anyone got to number 4 on the angle launch, but if not, now we can do the rest of them. The last 2 are angle launch delta y does not equal 0 problems. And yeah, so tomorrow, Friday, I'll do an angle launch progress quiz probably with you right away to start. Then I'll give you some work time. I had said test Monday, but I might push it back to Tuesday. I'm going to push it to Tuesday. So we'll test next Tuesday. Realize Wednesday is the last day because you have that 4-day weekend. So I'll push it to Tuesday, which will then leave Monday with some kind of time to do some review stuff in class or tie up any loose ends. So that's the plan for kind of the rest of the week. We'll test Tuesday on 2D motion. Same kind of idea. There's going to be a concepts and a calculation portion. So let me know what questions I can answer for you, and we'll move on.